So today we'll be going over the factor theorem, and then we'll see how it is used to help us determine if a polynomial is a factor of another polynomial. Okay, all right. Let's get to it. The theorem says that a polynomial f of x has a factor x minus a if and only if f of a equals 0. All right, so I'm gonna have to illustrate this with an example for us to actually really get it down. So here is an example. Here is a polynomial. F of x equals x cubed plus 2x squared minus 3. So the question is this. Sometimes I want to know is x minus 1 a factor of f of x? This is the question. I want to know if x minus 1 is actually a factor of x. Another way of asking the same question would be, well, remember, let's just back up to ordinary numbers. If I divide, well, if I say, is 4 a factor? Is 4 a factor of 12? Well, that's a good question. So how would I find out if 4 is a factor of 12? Well, I can divide 12 by 4 and see if there's a remainder or not. So if I divide 12 by 4, so 12 divided by 4 is 3, and there's no remainder. Remainder equals 0. That means really 4 is a factor of 12. It's the same thing that we're actually doing over here. So we're going to actually divide. We're going to divide. So we're going to divide x cubed plus 2x squared minus 3 divided by x minus 1 and see if there is actually a remainder or not. But remember that if there is a remainder, then it's not a factor. If there's no remainder, then it is a factor. Now, we're not interested in the quotient. What is the quotient we're going to get? We're only interested in the remainder. We want to check if it's 0 or not. So let's test now. Remember from the remainder theorem, if we're interested only in the remainder, we don't need to go through the whole process of division. We can just do f of 1. Right? We have to set it to 0 and set it to 1. So we're going to just test what is f of 1. Okay, let's see what f of 1 is. Now, f of 1. So we're just going to try 1 cubed plus 2 times 1 squared minus 3. Let's see what that gets us. So, here we go. 1 times 1 times 1 is 1. So that's 1. 2 times 1 squared is 2. And then minus 3. Now, 1 plus 2 is 3. 3 minus 3 is 0. So f of 1 is 0. So we can say, since f of 1 equals 0, then there is no remainder. Remainder equals 0. So remainder equals 0, that means that actually x minus 1 is indeed a factor of f of x, which is what we are after. We just want to know if x minus 1 is a factor. If you plug it in, you got 0, then you know it's a factor. If you plug it in, you didn't get 0, then it's not a factor. We have to do more examples for us to actually get it down more. So here is another example. So, is x plus 3 a factor of x squared minus x minus 6? So I'm interested in finding out the answer to this. Well, this is my f of x. All I need to do is to plug in x equals -3 into there. So we're going to do, well, we're going to do -3 squared minus -3 minus 6. We want to see if that is 0 or not. We don't know. Let's check. -3 squared will be 9. And then negative times -3 will be +3 minus 6. When we do this, we'll do 12 minus 6, which is 6. That is not equal to 0. So we can say that x plus 3 is not a factor of x squared minus x minus 6. We can just say that because we did not get 0 after we plug it in. Here is another one. What if I wanted to test? There's an f of x equals s squared plus 2x minus 8. So I want to know, is x plus 4 a factor of f of x? Okay, so don't worry about this telephone ringing. We move on. So what we're going to do is we're going to do f of what? This is -4. We have to set it to 0. Don't forget it's the opposite of this that we're going to test it with. What is f of -4? Okay, let's see what that is. -4 squared plus 2 times -4 minus 8. Let's see. -4 times -4 is 16. And 2 times -4 is -8 minus 8. And so we get 16 minus 16, which is 0. All right, so we got 0. That tells us that, therefore, x plus 4 is a factor of f of x. Which equals s squared plus 2x minus 8. So the factor theorem helps us to actually quickly find if a linear factor is a factor of a function. Really quick and easy. All right, I hope this helps. Thanks for watching.